In our series of 50th anniversary, I'd like you to meet today with Kevin Byrne. Tell us about your first designs at Sabre Yachts, sort of transition to where we are today.
It's really intriguing because I think all of us, from boat owners to people in the boat business, have seen this in the last 15 years. We've gone from boat handling that had not changed in generations. And, we had straight shaft boats, and it was either a twin or a single. And maybe you had a really modern boat if you had a bow thruster,
Right.
So that's where we really started. So the first designs that I worked on, were the Sabre 54, the Sabre 456 sailboat. We were really living in that world of straight shaft boats with rudders, and we did have bow thrusters and stern thrusters were a fairly mature technology, but they were pretty much an on-off proposition. And the complexity of handling a boat, you take like a Sabre 52, and you talk about handling that boat in a modern marina, in and amongst other 52-foot boats. Tremendous amount of anxiety associated with that, unless you're doing that every single day, 3 times a day for a living. It's a daunting proposition to move boats in and out of places like that, which are common. And so the level of enjoyment it cannot be overstated. When you talk about going from the anxiety associated with handling boats in that situation to today in 2019, it's a completely different environment. And so the ability of our boats to maneuver around the dock, the ability of our captains to be able to confidently handle these boats in and out of very tight spaces has changed and improved exponentially, really, in the last 15 years. And that contributes so much to the enjoyment of operating a boat and to owning a boat and to enjoying a boat with your family without the stresses of these very difficult maneuvering situations. We owe a lot to our access to information that we have today, our engineering team's competency and ability to identify and execute improvements is dramatically better than it was 15 or 20 years ago. We just know a lot more about almost everything, and we have an ability to capitalize on that, starting at the very beginning of the design phase, where we can 3D model every single screw and every single stick of wood in this boat. The idea that this boat could go 30 plus knots at 65 or 64 decibels would be completely unheard of 15 years ago. It just wouldn't have happened.
Yeah. Now, you mentioned 3D as a modeling tool, but you've also been involved in the University of Maine's 3D printing project, which is made quite popular by its recent printing of an actual boat. Tell us a little bit about our involvement in that and what you look forward to being able to use those machines for.
Well, I couldn't be more excited about where we are going as an industry, and that a lot of this is being spearheaded right in our home state of Maine. The University of Maine is a fantastic engineering apparatus, both for the commercial side of things and for the students. And so we've been fortunate enough to have a relationship with them where we consult with them on some of the realities of the economics surrounding some of the 3D printing stuff. But what's really exciting is the technology. And what we hope to do, if we could kind of fast forward into the future, I think where we'll find ourselves is that what we'll be doing is 3D printing our molds that we use to make all of our composite parts come out of molds. And those molds are very intensive to build right now. They create a lot of, they use a lot of energy, they use a lot of materials that gets thrown away in order to get that final result of a fiberglass mold. And what we're looking to the future to hold for us is that instead of doing all that, we're going to have this big 3D printer that's printing the molds directly out of a renewable resource, so out of a recyclable material. So the idea is that ultimately we could be 3D printing this mold for, say, a hull, using it for the duration of the production that we want to get out of that mold, the number of parts we want to get out of that mold. And then when we're finished with that, instead of throwing an enormous multi-thousand-pound piece of plastic into the landfill, what we'd be doing is grinding up that mold into a material that we can run back through the 3D printer and 3D print the next mold.